Okay, I'll be referring to this document, functions. Looks something like this. I already went ahead and put example 1 on the board. I'm not going to write every single thing that it says. I'm just pretty much just going to do the problems and tell you what page we're on. Okay, so example 1A says determine if this is a function. Well, you guys can read the definition of a function. A function involving numbers is a relationship between numbers with an input variable and an output variable, and each value for the input variable has only one output. Okay, so to determine whether this is a function or not, we're going to go ahead and write the input variables and the output variables in order. So I got the lowest input variable I see is -2. The first coordinates are the input variables. So -2, -1, 1, 2, and 5. Okay? We also have the lowest output variable I see is value is 0. And then we have 3. Then 4. Okay, I'll write 4 only once. And then we have 7. Now, -2 is matched with 3. -1 is matched with 0. 1 is matched to 4. 2 is matched to 7. And 5 is matched to 4. Each one of these input variables has only one output. Okay? Only one arrow coming from it. So this is a function. Okay? This is a function. Okay? The domain is a set of inputs. So the domain would be -2, -1, -1, 2, and 5. The range is the outputs. Range. 0, 3, 4, and 7. Okay? Example 2. I'm going to pause this and put example 2 on the board. All right, example 2 is on the board, and we're going to repeat the same process. It's the same questions. A, is it a function, and if so, to identify its domain range. So the inputs and the outputs. Okay? Lowest input I see is -5. I have 0. I'm not repeating the 0. Then there's 7. Okay? The lowest output I see is 1. Then 3. Then 4. And then 6. All right, -5 is matched with 6. So far this is a function. 0 is mapped to 1. And then 0 is mapped to 3. This is not a function. That right there disqualifies us from being a function. This input has two outputs. All right, now 7 is mapped to 4, not that it matters at all. Okay? This is not a function. Well, it's not a function. So since it's not a function, it doesn't have a domain, it doesn't have a range. Okay? So if it's not a function, it doesn't have a domain, it doesn't have a range. That's the reason why I chose the words inputs and outputs. Okay? Because just because it's an input doesn't mean it's a domain. Just because it's output doesn't mean it's a range. Okay? It has to be a function. So here's the difference. All of these inputs had only one arrow going out from them, matching them to an output. Now, this output had two inputs, but that doesn't matter, okay? Outputs can have multiple inputs, but inputs can only have one output, okay? So this disqualifies this from being a function, okay? Okay, I admit this is the first time I'm doing this with a projector. So you'll have to please bear with me as I try to make this work. Okay, so we're on page 2, and here's example 3. Okay, example 3. The graph of the relation is below. Answer the questions. So there's something called the vertical line test. You can read about at the top of page 3. It says that in graphs, the input variable is the horizontal axis. It's normally x. The output variable is on the vertical axis. It's normally y. Okay, I'm reading something that's off screen. If the graph is a function, a vertical line should cross it only once everywhere. That would mean that every x has only one matching y. If it crosses more than once, the graph is not a function. So I will actually be stacking up all 3 of these markers to determine if this is a function. Okay? And as I run across, this vertical line crosses only once everywhere the function exists. Okay? Vertical line. Okay? If you want to put an imaginary vertical line between the markers, and it crosses once everywhere. Okay? This is a function. The next appropriate question would be its domain and range. The domain goes from, let's see if I can get this thing closer to it, even though you should have your own printout. Okay? This is -1, this is -2. So this point is -2. 1, 2, 3, 4. -2, 4. And this is 2, 3, 4, 5. This is 5, 6. Okay? So, the domain goes from x equals -2 to x equals 5. So that's -2 is less than or equal to x, which is less than or equal to, I'm going to rewrite that, which is less than or equal to 5. Okay? Or in interval notation, those are closed dots. So -2 to 5. Okay? The other part asks about the range. The range is the set of vertical coordinates that exist. So the low point here is 0, 0. Okay? So the range goes from 0, the y coordinates go from 0 up to 6. That's the range. 0 is less than or equal to y, which is less than or equal to 6. Okay? The range, the set of vertical coordinates that are available. 0 is the low y value, 6 is the high y value. So, 0 to 6, okay, with brackets. Okay, I'll put the next one on the board. Example 4. Now, if you'll notice, these have arrows. Okay, that means they go on forever in those directions. Okay? Now, if we run our vertical line across, it crosses once everywhere. Okay? So, this is also a function. Now, the domain. These arrows indicate that it will go on forever in both directions. Okay? Go forever in both directions. So as a consequence, the domain goes forever that way, it goes forever this way. So the domain is all real numbers. Okay, all real numbers. In interval notation, that is described as negative infinity to infinity. The range, well, that's a different story because that's the low point. Okay? That's the lowest y value. There's no limit to how high the y's can go. Okay? So it's y is greater than or equal to 0. Okay? Because that's the lowest y, but the y's can be forever up. Okay? In interval notation, that would be described as 0 to infinity. Okay? Because again, the domain, as far as the x's are concerned, it goes forever this way. Okay? But as far as the y coordinates go, there's a lower limit, but there's no upper limit. Okay? The y's can go up forever. Right, I'm going to switch sheets again, so I'll pause at this point. Okay, the question here is, so we're on page 4. Example 5 asks if this is a function, and if so, what is its domain range? Well, so far so good. It crosses only once, crosses only once, crosses only once. Now it crosses twice. Okay? Crosses twice, as you can see. So this is not a function. This also, so it would. This is a function so far, and then it stops being a function when it has 2 crossing points. Okay. This would be fine. This would be fine, and again, this would not be fine. That's 2 crossings as well. Okay. So this is not a function. Since it's not a function, it doesn't have a domain or range. Now, for example 6, I provided another graph, and it says, what is the domain range of the function below? Well, I already told you that this is a function. Okay? That information was provided. That's a function. Okay? So that's not a yes or no question about whether it's a function or not. I told you it's a function. The question asks, what's the domain and what's the range? Well, these arrows indicate that it continues forever in this general direction. Ditto down here. Okay? So the domain is all real numbers. It extends forever. Or in interval notation, negative infinity to infinity. So that's where that comes from. The range, it can go up forever, it can go down forever. Okay? So it goes on down here forever, it goes up forever. So the range is also all real numbers, described as negative infinity to infinity. Okay? So I'm going to pause now and change pages. 5. And with example when we have f of x equals 5 minus 4x, find f of negative 11. The steps on top of the page say plug a value in parentheses in for the variable, simplify, and calculate. So f of negative 11 would be 5 minus 4 times negative 11. Okay? I'd multiply that first, so that would be 5 plus 44, which is 49. Okay? This one, f of 3 would be 2 times 3 squared plus 5 times 3 minus 17. Well, 3 squared is 9. 9 times 2 is 18 plus 15 minus 17. 33 minus 17 is 16. All right. Here I have f of x is 4.1 to the x minus third. F of 5 would be 4.1 to the 5 minus third. You will want to simplify the exponent first, and that would give you 16.81. Because 4.1 squared is 16.81. Okay? I'm going to clear the board off, and I'm going to put up the next two examples. Here's what we do for example 4. G of negative 6 would equal the square root of 3 times negative 6 plus 34. That's negative 18 plus 34. Okay, add these two up, you get the square root of 16. The square root of 16 is 4. Okay, now for this, I'm going to do the top and bottom separately. Okay, and then I'll combine the results later. Actually, let me go ahead and finish the problem. Find f of 4. Okay, so I have f of 4 equals the fifth root of 4 plus 1020 over 3 times 4 minus 13. Okay, the top, I'll do the top and bottom separately. The top is going to be the fifth root of 1024, which is equivalent to 1024 to the 1/5 power. Okay? If you take your calculator, and I will, even though I know the answer, I'm going to go through the motions. It'll be 1024. I'll hit my generic exponent button. They vary from calculator to calculator. I will open a parenthesis, 1 divided by 5. I will close the parenthesis, hit enter or equal. I got 4. Okay? But that's 12. 12 minus 13 is negative 1. So, combining the results, I have 4 over negative 1. 4 divided by negative 1 is negative 4. Okay? So that's what you should do when you got fractions, and with any sort of complication to them. Do the top separately, do the bottom separately, and then combine the results and simplify. All right, I'm going to pause here and change and go back to the graph. 6. I went ahead and provided the function, and I provided its graph. Okay? So it says to find f of negative 1. Okay, f of negative 1, if I was going to do it by graph, so AA is algebraically, okay? So that would be negative 1 cubed minus 3 times negative 1 plus 4. Okay, that's going to be negative 1. Negative 3 times negative 1 is positive 3, plus 4, I get 2, plus 4 is 6. Okay, now if I was to do this by graph, here's the graph. Okay, by graph. So here is x equals negative 1 on the graph. I will either go up or down to meet the appropriate coordinate on the graph. So 1, 2, 3, 4, 5. Hold on a second. Okay, so here it goes. So I got x equals negative 1. I will go up or down to meet the curve or the line or whatever. So x equals negative 1, and then I will go straight up, and the y coordinate is 6. Okay, so at x equals negative 1, y is 6. Okay, so f of negative 1 is 6. All right, I'm going to do the same thing on page 7. Okay. I'm keeping the same function. All right, this time I'm going to switch the order around. Find f of -2 by graph. So I'll do B first. Okay? B. Find f of -2 by graph. Then I'll do A. Okay, so here's where x equals -2 is right here. Okay? X equals -2. I'm going to go up and I'll meet the graph and it looks like the y coordinate is 2. Okay? X equals -2, y equals 2. Okay? So f of -2 is 2. Okay? I'll follow these up with more examples. A, we'll confirm it. F of -2 is -2 cubed minus 3 times -2 plus 4. Let me move this down first to avoid confusion. A, f of -2 by graph would be -2 cubed minus 3 times -2 plus 4. All right, so -2 cubed is -2 times -2 times -2, which is -8, plus, this minus times a minus is a plus, and then plus 4. -2 plus 4 is 2. Okay? More. Okay? Let's talk about more. Okay? Which is not on your graph. Well, let's talk about, say, f of 0. If I go to x equals 0 on the graph and go up to meet it, it's 4. Okay? Let's say I want f of 1. Well, I go to where x equals 1, 1 on the graph, and I go up to meet it at 2. Okay? So that's the basic idea. Okay? So now we're on page 8. Okay? And as you can see, there is no rule for this function. Okay, I didn't provide one. It's not available. There is no f of x equals. Okay, it looks like I need to move this thing around some. Okay? There is no y equals rule here. This is all we have. We have just this graph and only this graph. Okay, so here's f of x. There's no rule that you can plug numbers into. So to find f of 2, well, let me go ahead and put this down there. Okay, f of 2. We're going to go to where x equals 2 on the graph. I'm going to move up or down to find the matching y. So at x equals 2, y equals 1. More. Okay, I'm going to ask for more examples. So we'll talk about, say, f of -1, f of -2, f of 0, and f of 4. So f of -1, I'll go to x equals -1 on the number line, and I will go up and meet a y coordinate of 1. At x equals -2, I go up and I meet a y coordinate of 4. When x equals 0, the y coordinate is also 0. And at f of 4, I will go to where x equals 1, 2, 3, and 4. And when I get there, it's the y coordinate is 2. Okay? All right, we are on page 9. Here we have f of x graphed. And the question asks, what f of 5 is. Well, f of 5 is, I go to where x equals 1, 2, 3, 4, 5. Okay, so here's where x equals 5. I'm going to go down to meet the graph, and the y-coordinate is negative 1. Okay, I'll do that again. I'll go to where x equals 5, 1, 2, 3, 4, 5, and I will either go up or down to meet the curve. Looks like it's down in this case, and the matching y is negative 1. The next question asks the domain. Well, these lines go forever both ways. Okay? So horizontally, it's all real numbers. Interval notation, that's negative infinity to infinity. Now the range is not so simple. The range, it goes down forever. These arrows mean this is going to go down forever. But there's an upper limit to the y, and that is 6. Okay, so the upper limit is 6, but there's no limit to how low they can go. So y is less than or equal to 6. That's the upper limit, but there's no lower limit. Okay, interval notation, that would be the lower limit would be negative infinity, but the upper limit would be 6. Okay, that's the highest y-coordinate we can have. The y-intercept, that's where it crosses the y-intercept. It crosses at 0, 5. The x-intercepts are where it crosses the x-intercept, or the x-axis. So that would be negative 2 is the x-coordinate. 0 is the y-coordinate. And the other one is this 4, 0. All right. I'll pause it. All right, so here I am I'm planning to sketch this graph. Actually, give me a moment. I went ahead and turned off the document camera. I don't need it anymore. Okay, I'm not going to need it anymore. I'm not going to need the projector anymore. And I'm going to zoom this thing back so I can actually see everything. And you can actually see everything. It's all in on the board. Okay. Now what I propose to do is I propose to sketch the graph of this function. You have a copy on your paper, your printout. Now, this is the starting point. Here's the function we have to sketch, and here's the graph the grid that we have available. And I'm going to make it very simple for you, folks. If it doesn't come anywhere close to fitting, don't bother plotting it. Okay? So, in the absence of any other method available to graph these, we're just going to start at the left and work our way across to the right. So at x equals negative 4, this takes the role of y. So y would equal negative 4 cubed minus 3 times negative 4 plus 4. All right? I start here at x equals negative 4. So this is negative 64. That's plus 12. That's plus 4. All right? So negative 64 plus 12 plus 4 is negative 48. So the first point would be negative 4, negative 48, which doesn't come anywhere close to fitting, because that would be negative 4, and that would be way down here below. Okay, so it doesn't come anywhere close to fitting, so I won't even bother to plot it. X equals negative 3. So we did negative 4, now we'll do negative 3. Y equals negative 3 cubed minus 3 times negative 3 plus 4. So that's negative 27 plus 9 plus 4. So negative 27 plus 9 plus 4, negative 14, which doesn't come anywhere close to fitting. That'd be negative 3, negative 14. Okay? Doesn't come anywhere close to fitting, so we won't worry about it. Negative 4 is done, now negative 3 is done. Now we'll do negative 2. So everywhere where I see an X, I stick in a negative 2. That's negative 8. That's 6. That's plus 4. So negative 8 plus 6 plus 4 is 2. So that's negative 2, 2. Okay, if you want, you can plot it at this time. Negative 2, 2. All right, so negative 4, negative 3, negative 2. Now we'll do X equals negative 1. Y will equal negative 1 cubed minus 3 times negative 1 plus 4. Okay? So that's got to be negative 1 plus 3 plus 4. That's going to be 6. So negative 1, 6 is the point. Negative 1, 6, right there. All right? So now we'll do X equals, we've done negative 4, negative 3, negative 2, negative 1. Now we will do 6. Sorry, we will do 0. Okay? So X equals 0, Y equals 0 cubed minus 3 times 0 plus 4. Okay? I understand there's a bit of a glare there, so I think I'll move this down again. Okay, so we did negative 4, negative 3, negative 2, negative 1. Now we'll do X equals 0. X equals 0. Y equals Y equals 0 cubed minus 3 times 0 plus 4. Okay, so that's 0 minus 0 plus 4 is 4. So we have 0, 4. Okay, so we did negative 4, negative 3, negative 2, negative 1, 0. Now we will do 1. X equals 1. Y equals 1 cubed minus 3 times 1 plus 4. Okay? So that's going to be 1 minus 3 plus 4. That's 2. So 1, 2. All right. Now we'll do X equals 2. Y equals 2 cubed minus 3 times 2 plus 4. Okay? So that's 8 minus 6 plus 4. 2 plus 4 is 6. So 2, 6. All right. X equals 3. Y equals 3 cubed minus 3 times 3 plus 4. 27 minus 9 plus 4. I bet it doesn't even fit. 27 minus 9 plus 4, 22. So 322. Doesn't come anywhere close to fitting. 322 would be way up here. And then finally we'll do X equals 4. Y equals 4 cubed minus 3 times 4, or minus 3 times 4, and then plus 4. That's 64 minus 12 plus 4 56. So that'd be 4, 56, which doesn't come anywhere close to fitting in the grid. So we're going to draw a curve that fits this general, that hits all these points. So we didn't have anything for these values. This is the first one we had, negative 2, 2, but all the other ones previously were far lower. Okay? And then, let's try and make a curve look curve-like. Okay? Actually, I'm going to start this over. Okay? I'm going to play a game of connect the dots with the dots we have. So up, back down, here, and then back up. Now, what happens here is that before negative 2, it was lower. So we're going to show an arrow that drops. Okay? And then for after x equals 2, we were going up higher. So our arrow should show us going up higher. And there we go. Okay? You don't need to overthink these. These are just hand-drawn sketches. All right? So I'm going to clean this board. I'm going to clean this off and do the next page. Okay, this is called a piecewise function. Okay, what we're going to be doing here is it's a function which follows different rules depending on where we're at. This is one piece. If x is less than 3, we'll follow that rule. When x is 3 or more, we'll follow that rule. So the boundary is x equals 3. So I'm going to go ahead and put a dotted line. This is in standard, but it's what I usually show students to do. The boundary point is here at x equals 3. Okay? So this is piece number 1. This is piece number 2. Okay? Now, I generally start with the piece that's farthest to the right when I'm showing students how to do this. So the farthest to the right is piece number 2. Okay, and the rule for piece number 2 is that y equals, so this is piece number 2 right here. Okay, the rule is that y equals the square root of x plus 1. Okay, and that is when x is greater than or equal to 3. Okay, so there will be an endpoint, and that's going to be a closed dot because of the or equal to. If it was a strict inequality sign, it'd be an open dot. You'll see that next. Okay, so at x equals 3, endpoint x equals 3. Y equals the square root of 3 plus 1, okay, which is the square root of 4, so y is 2. So we have 3, 2. Other points. That's the end point. Here's the other points. Other points such that x is greater than or equal to 3. Well, we already did 3, so how about x equals 4? We'll do the next integer value. Y equals the square root of 4 plus 1. Okay? Which gives me the square root of 5. So it's not approximately equal to. It is equal to. Okay? And the square root of 5 is approximately 2.236. You can round as approximate as you want, since there are no rounding instructions. Okay, so there's another point. Next we'll do 5. So y equals the square root of 5 plus 1, which is the square root of 6, which is approximately 2.45. So that's going to give me 5, 2.45. We can plot we can go ahead and plot these if we want. I'll say I'm going to hold off until we got this piece done. Then we have x equals 6. Y equals the square root of 6 plus 1, which is the square root of 7. Square root of 7 is approximately 2.646. So we have 2.646. All right, so let's go ahead and plot these things. We determined that this is going to be this endpoint will be a closed dot, so that's 3, 2, because of the or equal to. We also have 4 and about 2 1/4. That's almost 2 1/4. Okay, that's almost 2 1/2. So 5, a little bit under 2 1/2. And then 6, and then 2.646 something. So almost 2/3. And it's a radical function, so it's going to have a curved shape to it. All right. So we also need to do piece number 1. Okay. That is going. So if this piece number 2 goes this way, any other piece would have to go this way. Okay. So piece number 1. That follows the rule. Y equals the absolute value of x plus 2. And the rule for piece number 1 is x has to be less than 3. It's not or equal to, so it's going to be an open dot. It's not or equal to. And the endpoint for this is going to be x equals 3. Of course, that's got to be an open dot, so actually, well, that's fine. It's got to be an open dot. Let's plot. Y equals the absolute value of 3 plus 2, which is the absolute value of 5, which is just 5. So it's 3, 5. I'll go ahead and plot it with an open dot. 3, 5. Okay? Next up, we need other points with the restriction that x has to be less than 3. So 2, 1, 0, and so on. So x equals 2, y equals the absolute value of 2 plus 2, which is the absolute value of 4, which is 4. So 2, 4. We'll go ahead and plot these. These are going to be with closed dots. Okay? Only endpoints can be open dots. Only endpoints. Okay? And that's only under certain circumstances. Okay? And that circumstance is if it's an endpoint and there's no or equal to. Everything else is going to get a closed dot. All right, so we did 2. Now we'll do 1. Y equals the absolute value of 1 plus 2, which is the absolute value of 3, which is just 3. So 1, 3. Okay? One, 3, 2, 4. All right. Then we did 2, we did 1, now we'll do 0. Y equals the absolute value of 0 plus 2, which is the absolute value of 2, which is just 2. So 0, 2. Okay? Next up, we did 2, 1, 0. Now we'll do x equals negative 1. Y equals the absolute value of negative 1 plus 2, which is the absolute value of 1, which is just 1. So negative 1, 1. Okay? And then we'll do negative 2. y equals the absolute value of negative 2 plus 2, which is the absolute value of 0, which is 0. So negative 2, 0. All right? Next, negative 3. Y equals the absolute value of negative 3 plus 2, absolute value of negative 1, which is 1. So, negative 3, 1. Negative 3, 1. Okay? And finally, x equals negative 4. Y equals the absolute value of negative 4 plus 2. Absolute value of negative 2, which is 2. So 4, 2. Or negative 4, 2. All right. And absolute value, most absolute value equations are functions are going to be V-shaped. All right. All right. As I said, normally the dotted line isn't going to be there. So I'm going to go ahead and erase this. And usually the graphs of piecewise functions are going to look something like that. All right, so at the next page. 12. Okay, we're going to be talking about domains by algebra. Okay, I went ahead and put example 1 on the board. Domain, the values that you can plug in and get a real valued output. The most common restrictions, denominators cannot equal 0, and for square roots, the radicand has to be greater than or equal to 0. Okay? So, you know, while I'm at it, I think I'm going to go ahead and put examples 2 and 3 on the board. Okay? First of all, when you're talking about just the domain, you only worry about what's relevant. So, for instance, to find the domain of this function, then this is a denominator. X minus 13 cannot equal 0. Okay? If we add 13 to both sides, it means that x cannot equal 13. Okay? Because that would make the denominator equal to 0. Now, in interval notation, this would be described as negative infinity to 13, or 13 non-inclusive to infinity. Okay? Let me draw you a picture of what this would mean. Okay? X cannot equal 13. So it can be anything less, it can be anything more. So these are two disjoint regions. So this interval describes this region. This interval describes this region. Okay. Find f of negative 5. Well, f of negative 5 would be negative 5 plus 15, or sorry, negative 5 plus 5 over negative 5 minus 13. So if we're finding the function value, we're actually going to plug them in to everything. So this is going to be 0 over negative 18, which is 0. Numerators can equal 0. Denominators cannot. Okay? Find f of 14. Well, 14 plus 5 over 14 minus 13 is 19 over 1, which is 19. Okay? F of 13 would be 13 plus 5 over 13 minus 13, which gives you 18 over 0, which doesn't exist. Okay? There is no division by 0. Okay? So that's the reason 13 is not in the domain. Okay? 13 is excluded from the domain because it doesn't give a real valued output. Now, what's relevant here is we simply have to conclude that x minus 15 has to be greater than or equal to 0. Okay? The square roots of negative numbers are not real valued. The square root of 0 is 0. and the square root of a positive number is a real value. Okay, so we're going to set the right-hand greater than or equal 0, because it's a square root function. We'll add 15 to both sides, and we get x has to be greater than or equal to 15. Or in interval notation, 15 is a low value. There's no limit to how high x can go. Square bracket for the or equal to, parenthesis for the infinity. Okay, if you're required to do interval notation. Now for a cube root function, this doesn't apply. So this is answer, all real numbers. Remember, the cube root of a negative number is a negative number, which is real value. The square root of the cube root of a positive number is a positive number, which is real value. That's different from the square roots of negative numbers. Square roots of negative numbers are not real value. So interval notation, all real numbers is negative infinity to infinity. Notice the difference between a square root and a cube root. Okay? Square roots, the right-hand has to be greater than or equal to 0. Cube roots, it's not an issue. Okay? Let me clear off the board. All right, next up, I want to do example 4 on page 13. Okay, so here we go. Here to find the domain. We're going to replace this with the factored form. Two factors of negative 1/9 to negative 9 are negative 19 and positive 9. Okay? So the denominator cannot equal 0. Okay? So the only way that this could, to avoid 0, is if x minus 19 does not equal 0, or x plus 9 does not equal 0. Because if either of these was to equal 0, the denominator would equal 0, and that would make this function be undefined. So we will add 19 to both sides. X cannot equal 19. We subtract our 9. X cannot equal negative 9. Now, so the traditional way of saying this would be to say all real numbers, with the exception that x cannot equal negative 9 or 19. Interval notation is a little bit more complicated. Okay, so here's what we got. Okay, if we were to describe this in interval notation, we have negative 9 being excluded, and we have 19 being excluded. Everything else is allowable. Okay, but these two are going to have to be open dots, which exclude those values. So this interval would be described as negative infinity up to negative 9 non-inclusive. Okay, this would be described as negative 9 to 19 non-inclusive. And this would be described as 19 to infinity non-inclusive. Okay? That is what we will have to do to avoid these two numbers. All right. Example 5 on the board as well. Okay? Remember, no denominator in any part of the function can equal 0. So x minus 15 cannot equal 0. X minus 16 cannot equal 0. And x minus 17 cannot equal 0. All three of those things must be true. None of these denominators can equal 0. So add the 15. X cannot equal 15. Add your 16. X cannot equal 16. Add your 17. X cannot equal 17. So, in interval notation, I'm going to go straight to the interval notation. Okay, that's got to be negative infinity to 15, union 15 to 16, union 16 to 17, and union everything after 17. Okay? You can see traditional notation on the paper. Okay? I'm going to clear the board. All right, and I put a number of other examples on the board as well. Okay? And I'll be doing them in a different order than what they are on the paper. Okay, I'm going to go ahead and fill this in while I'm at it. Okay, so here goes. This is actually equivalent to g of x equals 1 over x to the fourth plus 5 over x cubed plus 26. Okay, so that means x to the fourth cannot equal 0. X cubed cannot equal 0. Well, folks, the only way for a number to the fourth power to be 0 is if the fourth root is 0. So that's 0. Ditto, x cannot equal 0. Okay, that's what the long and short of this. So it's negative infinity to 0, non-inclusive, and 0 to infinity. You guys can see what traditional notation would have looked like. Okay, I believe. Double check. Well, it doesn't matter because at this level you shouldn't have any trouble with interval notation anyway. Okay. So here we go for the next part. F of x. So I went ahead and compared that with example 8, which would be f of x equals x to the fourth minus 2x squared plus 3x minus 14. Well, this, folks, is just a polynomial. Okay, so domain is all real numbers. This is something for you to be very careful of knowing, is that the domain is all real numbers, which interval notation would be negative infinity to infinity. The difference between these two functions is that has a negative exponent. These are positive integer exponents, 4, 2, and 1. Okay? This is a polynomial, and the domain is all real numbers. Now, let's talk about example 7. I'm going to remind you of both of the most common domain restrictions. After I get this written over. Okay. Denominators cannot equal 0. And for square roots, the radicand must be greater than or equal to 0. So we have two things going on here. Top, the radicand, 6x plus 72, has to be greater than or equal to 0. Okay? Bottom. Well, let's go ahead and finish this one up first. So subtract the 72. 6x has to be greater than or equal to negative 72. I'm going to go ahead and remove the bottom for now. Okay, divide off the 6. X has to be greater than or equal to negative 12. Okay? Bottom. We will be doing interval notation, but we're going to save it for the end. The bottom. I'm going to go ahead and factor this. X and x. Two factors of negative 42 that up to negative 11 are negative 14 and positive 3. Okay? So x minus 14 cannot equal 0. X plus 3 cannot equal 0. Okay? Add your 14. X cannot equal 14. Subtract your 3, subtract your 3. X cannot equal negative 3. Okay? So, how to combine these two? What I'm going to do is I'm going to set 3 number lines, all vertical to each other, with all 3 critical points on them. One for the top, one for the bottom. Okay? Top. X cannot equal negative, or it must be greater than or equal to negative 12. Bottom, middle. Based on the bottom, x cannot equal negative 3 or 14. And then this one's going to be to combine the two components. All three number lines are going to have all three of the critical points in numeric order. Negative 12, negative 12, negative 12, vertical. Okay, they should line up vertically. I will also have negative 3. These don't need to be to scale, just make sure it's vertical. And we have 14 over here. Okay. Now, to describe x is greater than or equal to negative 12, I'm going to put a closed dot over the negative 12. I'm going to shade the numbers that are greater than negative 12. For x cannot equal negative 3 or 14, I will put open dots over these two. And I'll shade in everything else. Now, what happens here is that for the third number line, I'm going to take all the critical points as given. And I'm going to shade the regions that they have in common. So there's no overlap here, but both of these are shaded. Both of these are shaded. And both of these are shaded. Okay? So now I have 1, 2, 3 regions to describe. Okay? So that's going to be closed dot for the negative 12, because it's already equal to negative 3, not inclusive. Union. Negative 3 to 14 and not inclusive. Union. 14 to infinity, not inclusive. Okay? Page 15. This is example, what was it? It was example 9, I believe. Okay, example 9. We're going to go ahead and deal with the same issues here. This is equivalent to x and x. I suppose I could have factored this first as well, but I won't do that. That's going to be, well, I suppose I could have done it as well here. X, negative 14, positive 3. Okay, this would be negative 16, positive 5. Okay? Let me go ahead and write that more legibly. X plus 5, x minus 16. All right, so top. Remember, for square roots, radicands have to be greater than or equal to 0. Okay? Add your 98. 7x has to be greater than or equal to 98. Divide off the 7. X has to be greater than or equal to 14. Okay? Bottom. X plus 5 cannot equal 0. X minus 16 cannot equal 0. Okay? So subtract your 5, x cannot equal negative 5. Add your 16, x cannot equal 16. All right, so I'm going to set my 3 number lines. They're going to have all 3 of the critical points in numeric order. Negative 5, negative 5, negative 5. I suppose I could leave a little bit of daylight here. 14 and 16. All right, so greater than or equal to 14 is going to be a closed dot. Okay, I went ahead and, so x is greater than or equal to 14, closed dots, shade the numbers that are greater. X cannot equal negative 5 or 16. That's going to be these two. Everything else can be shaded. All right. There's no overlap here. There's no overlap here. That's an open dot. Okay? So that's going to be that. That's going to be included. And There's overlap here, there's overlap there. Okay, again, there's no overlap here, and that's an open dot. Okay, so the only regions we have are 14 to 16, non-inclusive of 16, and 16, non-inclusive to infinity. Okay? All right. I propose to use this one for the final example on page 15. Page 15, example 10. And I believe that function is f of x equals 8 over the square root of x minus 21. A, find domain. B, find f of 121. So domain. The square root of x minus 21 cannot equal 0. Okay? So, if we square both sides, we get x minus 21 cannot equal 0, which means x has to be greater than or equal to 21. Okay? But this x cannot equal 21. I apologize. Okay? And also, I'm going to continue the problem over here. Okay? Also, radicans has to be greater than or equal to 0. So x minus 21 has to be greater than or equal to 0. So add your 21. X has to be greater than or equal to 21. But x cannot equal 21. We saw that before. Okay? So that leaves, if this says x has to be greater than or equal to 21, but it can't equal 21, then that means x has to be strictly greater than 21. 21 to infinity. B, f of 121 would equal 8 over the square root of 121 minus 21, which would be equal 8 over the square root of 100, which is 8 over 10, which is 4/5. Okay? And that is it for page 15. I'm going to pause here and set for the next part of the document. All right. This problem is relatively easy. You have a function here. To find f of 2, what we would do is we would go to where x equals 2, the matching y is -3. Okay? Example 6. Find f, or is the next example, which isn't on your paper. It's on your paper. If I want to find f of 6, I go to where x equals 6 and find its matching y, which is -7. Okay? Likewise, f of 4 is -5. Okay, now, this one, I got it. F of x equals x cubed plus 17x squared minus 18x plus 22. Find f of s. Okay, well, that's simple. F of s would equal s cubed plus 17s squared minus 18s plus 22. Everywhere where I see an x, I stick in an s. That's it. Okay? This one, f of z plus 7. Everywhere where I see an x, I'm going to stick in a z plus 7. Okay? Well, this is going to be z plus 7 times z plus 7. I'll go ahead and distribute this negative through. That's going to be minus 8z minus 56 minus 19. I keep that. Okay? I know the FOIL method. This is going to be z squared plus 7z plus another 7z's plus 49 minus 8z, and these two combine into minus 75. All right. I'm going to go ahead and finish the foiling here. Z squared plus 14z plus 49. That's 49, I apologize. Minus 8z minus 75. Okay? So altogether, this is going to be z squared. 14 z's lose 8 z's is 6 z's. And then 49 take away 75 is minus 26. All right. For this one, this is going to be f of x plus h equals x plus h squared plus 23. Okay? Which is going to give me x plus h times x plus h plus 23. Okay? X squared plus hx times another x times h plus h squared plus 23. There is one simplification that can be done. These two. X squared plus hx, another hx is 2 hx's, plus h squared plus 23. Okay? This is actually an important fact. X plus h squared is equivalent to that. I'll put that on the top of the board, and we'll proceed from there after I clear the board. All right. I went ahead and put up the fact that we just went over, that x plus h squared equals that. Here's why, okay, for your convenience. Now the difference quotient is a mathematical term that stands for f of x plus h minus f of x over h. And example 1 is that. Okay, we're looking for the difference quotient of example 1, which is f of x equals x squared plus 11x squared plus 17. Okay, what you're going to want to do is you're going to want to follow the steps I gave precisely. Okay, first, f of x plus h only. Okay, you're going to do that only. So we'll start with that. Okay, so that's going to be f of x plus h equals 11 times x plus h squared plus 17. Okay, we're going to use that fact. X squared plus 2hx plus h squared, and then outside the parentheses is plus 17. I will distribute this through, and I will have 11x squared plus 22hx plus 11h squared plus 17. Second, subtract the original f of x. So minus f of x. So I'll be subtracting the original 11x squared plus 17. The original f of x. Now what you will find is that the terms of the original f of x will cancel against the counterpart. 11x squared is being subtracted from another 11x squared. So those will cancel. This 17 is being canceled from another 17. That will cancel. So the only surviving terms will be 22hx plus 11h squared. Okay? The third step, according to this, which is what I follow, third, I will do this division by h. So third, f of x plus h minus f of x over h is just this stuff. Over the h. And both of these h's are going to cancel. Okay? One go down a power. So that h will cancel, leaving 22x. And then 11h squared divided by h is going to be 11h. Okay? Next up, I will do page 18, where f of x equals 13x squared plus 8x minus 12. Okay? First, f of x plus h equals 13 times x plus h squared plus 8x plus h. I'm not making the best use of word space. I apologize. I'll set this up again. Okay? So this is going to be page 18, example 2, and we're looking for the difference quotient of f of x equals 13x squared plus 8x minus 12. All right, so here goes. First, f of x plus h equals 13 times x plus h squared plus 8x plus h minus 12, which will give me 13 times, this is actually that, plus, oops, I forgot the other parenthesis, plus 8x plus 8h minus 12. So I'll be scooting back a little bit with each step. That gives me 13x squared plus 26hx plus 13h squared plus 8x plus 8h minus 12. Okay? Comes from all that. Second, minus the f of x. So we're going to subtract the original f of x. So minus minus 13x squared plus 8x minus 12. I'm going to cancel all of these against their counterparts, because this 8x is this 13x squared is canceled against that 13x squared. That 8x is subtracted from that 8x. And this minus 12 is subtracted from another minus 12. Okay? So the only survivors are the terms which have h's in them. 26hx plus 13h squared plus 8h. Okay, I'm going to reorient the arrows. Actually, let me just go ahead and do all that again. Okay, so this is going to be 26hx plus 13h squared plus 8h. Third, f of x plus h minus f of x over h is 26hx plus 13h squared plus 8h over h. Okay, and those h's are going to cancel against counterparts. So that would be 26x plus 13h plus 8. Okay, because the h's will cancel there. Go down, cancel, go down a power, cancel. All right, I'm going to clear the board, and we'll do the next part. Okay, we are now on page 19, and the end is finally near. What we're going to do here is we're going to find something called a derivative. Okay, now you may notice the difference quotient expression again, but there's a limit, and it says that h approaches 0. Now, what that means is not appropriate. It is not important at this point. Essentially, it means what this would equal as h gets closer and closer to 0. But again, that's not very important to the purposes of this problem. Here's what you would do. The same steps as we did before. Find f of x plus h. After being finished with that, subtract the original f of x, and you'll be canceling terms. Then you'll do the division we just did. Now here's what's last. You will let h equal 0 after you have done these three steps. After you have done these three steps, you will let h equal 0, plug in, and then simplify. Here goes. Okay? Now again, well, you guys are probably thinking, h can't equal 0, that would make this undefined. The value is undefined, the limit is not. Okay? So if that's, don't worry too much about the details, just follow the steps. You will get a fuller explanation in a calculus class. So here goes of what limits are. But but algebra students, advanced algebra students should be able to do these steps. Okay, so here goes. First, f of x plus h equals 14 times x plus h squared minus 37. Okay? I just plugged x plus h in for x. All right, so that's going to be 14 times x plus h squared is x squared plus 2hx plus h squared. And then minus 37. Okay? Distribute. And we have 14 x squared plus 28hx plus 14h squared minus 37. Okay? Second, minus the f of x. So we have finished the first step. Now we'll do the other step, which is to subtract the original f of x. Okay? And again, these are going to cancel against counterparts. 14x squared is canceled against 14, is subtracted from 14x squared. That's going to cancel. Minus 37, minus another minus 37. Canceling, subtracting something from itself, these will cancel. So my surviving terms will be these two. 28hx plus 14h squared. Okay? Next up. Third, f of x plus h minus f of x over h is 28hx plus 14h squared over h, which gives you 28x plus 14h, because this will go down a power and that h will cancel entirely. Last, and not before, last, h equals 0, so I will have 28x plus 14 times 0. Okay, which gives me 28x plus 0. The derivative is 28x. That is your derivative. All right. Now I'm feeling super ambitious, so what I propose that we do is see if I can't fit I don't think I can. Okay. Let's see. Let me pause this and see if I can make other. I'll give it a whirl. If it fits, it fits. If it doesn't, it doesn't. Okay? All right, so here goes. First, f of x plus h would equal negative 6.12 x plus h squared plus 44 x plus h plus 21. First of all, before we go any further with this, let me tell you where it comes from. The object is on Mars, and the object is going 30 miles per hour on Mars and 21 feet high. Its height after x seconds is modeled by this, okay, in feet. This is related to the gravitational force on Mars. 30 miles an hour is actually 44 feet per second, and we're starting at 21 feet high. That's where that comes from. And that's not a priority where that comes from. That's in case you're curious. Okay, it's not important where it comes from. Okay, so I'm going to plug in x plus h in for x. That's going to give me negative 6.12. I'm going to have to write smaller. Okay, times x squared plus 2hx plus h squared plus 44x plus 44h plus 21. Okay. When I distribute these, this is going to be negative 6.12x squared minus 12.24 hx minus 6.12 h squared plus 44x plus 44h plus 21. Second, minus f of x. So minus 6.12x squared. Well, I'm going to have to. So I'll go ahead and copy this over. So minus 6.12x squared plus minus 12.24 hx minus 6.12h squared plus 44x plus 44h plus 21 minus 6.12x squared plus 44x plus 21. And I'm not having a good run at this. Okay, this might go better. All right, so these are going to cancel against the counterpart. Okay, all three of them. There should be no exceptions. The only surviving terms should have h's in them. Okay, so that's all right. Third, f of x plus h minus f of x over h is all this. Over h. All right. Since I'm getting tired, I'm going to start checking them more carefully. All right. So this is going to be negative 12.24 x, because that h will cancel. This is going to be minus 6.12h. And this h will also cancel. Okay? So, last, h equals 0. So we have negative 12.24 x plus minus 6.12 times 0 plus 44. And that's 0, so we have negative 12.24x plus 44. Okay? That's what's called the derivative. Now, folks, for the derivative at x, the derivative represents a formula for the rate of change. So the rate of change for this object's height at x equals 4 seconds, we have negative 12.24 times 4 plus 44. So I'm going to take my calculator. We have negative 12.24 times 4, and are equal, and then plus 44. That's negative 4.96. Okay? So that's going to be a fall of negative 4.96 feet per second. Okay? Because the time units are in seconds and the feet are in height. The height is in feet. All right, so you would get more of that in a calculus class. I just thought I would throw in an applied problem at this point. And I'm done.